Alright guys, so welcome back. So you just finished Sem 2 lesson just now, so a bit rush. Yes, okay, let's continue on our discussion for haloalkane. Today we're going to finish haloalkane and also alcohol, a bit only, just to revise back what is the reagent used and also some important knowledge on this particular chapter. Okay, so as per last recording, we done on SN1 and SN2 mechanisms. Okay, so SN1 for SN1 and SN2 mechanisms, it appears in your essay. Yeah, it appears in essay questions last semester. Okay, last semester, yes. Okay, last year. All right, so for your years, okay, you're just gonna focus it on your structure lah. Okay, you just have to focus SN1 and SN2 on your structure questions. Okay, like without further ado, let's continue on ethanolic silver nitrate test. Okay, so silver nitrate test is AgNO3 actually. Okay, so this test actually is to test the presence of halide ion. Okay, to test the presence of halide ion. Okay, of halide ion. So particularly we have Cl, Br, and also iodide. Okay, so if AgCl, you form a white precipitate. Okay, if you have AgBr, it will be a creamy yellow, be creamy PPT, creamy yellow PPT. Okay, whereas if AgI, particularly from you, a yellow PPT. Okay, it's a yellow precipitate. Okay, yellow precipitate. All right. So to double confirm the presence of halide, you can do ammonia test. Okay, you can add on ammonia test. All right. So AgCl dissolved in dilute. Okay, so the things will be something like this. Okay, let me draw for you. Oops. Can be okay. This is halide. UCL, AgBr, AgI. Okay, so we have dilute ammonia, concentrated ammonia. Okay, AgCl dissolved in both dilute and also concentrated ammonia. Okay, whereas AgBr only dissolve when you have excess ammonia, okay, which is concentrated. Okay, well for AgI, both are not dissolving. Okay, are not dissolving in both solutions. Okay, so to test the presence of halide ion, you can use NH3 lah, but NH3 is not necessary. Okay, it's not necessary. So for example, in case question asks you, suggest a test to test out haloalkane and also alkene. So what you can do, okay, you can perform this test lah by adding silver nitrate test. Okay. Okay, silver nitrate test. All right. So for primary haloalkane, the precipitate will take long times to form. Okay, take a long time to form, probably around 1 to 2 hours actually. Okay, it's not only for primary, same goes for aromatic. Okay, same goes for aromatic. Whereas for secondary haloalkane, we take around several times for 3 to 6 minutes. Okay, it will form. Okay, very quick. Okay, in very quick time lah. Whereas tertiary haloalkane will form immediately. Okay, immediately. Okay, so when you okay, this is your test tube actually. Okay, this is your test tube. So when you have RCl and this is a tertiary haloalkane and you drop out AgNO3 exactly, so you will form white precipitate immediately. Okay, immediately after you add in your AgCl. Okay, immediately. Okay, and then for aromatic, usually we can say that there's no precipitate form. Yeah, there's no precipitate form. Okay, but actually it's forming. Okay, it is forming, but it takes very long time. Same as primary haloalkane. Okay, same as primary haloalkane. Very long time. Very long time. Even you put in science lab, 3 to 4 days also it won't form precipitate because it takes very long. Take very long time to okay, you know that to break the structure, okay, to break the bonds in between your benzene and also your chlorine. This is the bond. Okay, this is your benzene ring, and this is your chlorine. Okay, so to break this bond, take very, very long time. Why? Because the lone pair electrons of chlorine are used by this benzene to delocalize, okay, to delocalize the system. So this actually make the bond in between benzene and also chlorine strong and strong and strong enough. So actually it take very, very long time to break that bond. Usually even when you heat up, also it take around 1 week to form precipitate. Okay, so like some explanations. So the equations of this actually is something simpler like this. Okay, so you have AgNO3. Okay, reacted with your haloalkane. Okay, so probably you'll form you R plus and O3 minus. So this is nitrate. Okay, nitrate and AgX. This one will be your precipitate, which have color, okay, which shows color. So this X is alright lah, depends on either is Cl, either is chlorine, either is iodine, or either is bromine. Depends on what types of crystals you form. For example, if you form a white crystal, which means that there are chloride. There are chloride presence. Okay, if you have yellow precipitate, means that there are iodide presence. Okay, so explanations on why chlorobenzene does not reactive or chlorobenzene does not give any precipitations. Okay, because we can say that chlorobenzene or other aromatic benzene have resonance structure. Okay, which make the structure stable and hard to break. So that's why the reactivities of chlorobenzenes or other aromatic haloalkanes are relatively very stable and hard to break bond. So usually we don't form any precipitate. Even you add up high concentrated silver nitrate into the test tube, which contain chlorobenzene, also won't give you any precipitation. Okay, like continues on this one. Okay, so in these chapters, haloalkane, we are going to focus on nucleophilic substitution reactions. Okay, so we have hydrolysis and also elimination. Hydrolysis, in which we are forming alkaline hydrolysis. Okay, alkaline hydrolysis. Okay, so your haloalkane will react it actually will be only primary lah. Usually it's primary. Okay, usually it's primary. Whereas for eliminations, it can be either secondary or primary. Let me see. Let me check out. Yes, actually it can be secondary or tertiary. Okay, it can be secondary or tertiary. All right. So reagent we have will be sodium hydroxide and also potassium hydroxide. Okay. For elimination, we are using the same reagent, sodium hydroxide, potassium hydroxide, but in ethanol. In ethanol, we have solvent for this. All right, the conditions will be room temperature, but this one no need to state. Okay, no need to state in your equation. Okay, just ignore this. Okay, whereas for elimination, you have to heat up. Okay, you have to heat up. Yeah, this one no need to state. Every room temperature, no need to state. Okay, no need to state. All right, so I give you one example here. If we have 1,1-dibromoethane, okay, 1,1-dibromoethane, it will be, okay, this is ethane. This is 1,1-dibromoethane. Okay, so when we perform alkaline hydrolysis, which is add on sodium hydroxide, so it will form, okay, something like this. And it will form you diol. And it will form you diol. Okay, depends on the numbers of halide you have. If you have 2 halide, then you form diol. If 3 halide, then triol. Okay, triol. Okay, if 1,1,1 trichloropropane, my God, who create these questions? Okay, 1,1,1 trichloro. 1,1,1 trichloropropane. Right, so you heat up with sodium hydroxide, aqueous solutions without ethanol, without solvent, so it will form alcohol. Okay, can I? Like next, okay, we go to elimination. So eliminations, we have one rules to follow. So the rules are called as ZZF rules. Okay, this one, okay, please delete this. Okay, usually we don't use say that. Okay, we use the correct statement. Okay, ZZF. Okay, ZZF. Okay, you just read it as this ZZF. Okay, ZZF. Okay, so these ZZF rules are elimination rule. Okay, we don't use say that. This even though these explanations, I mean like these terms, this name, okay, happens out in your textbooks, but usually these terms are incorrect. Okay, we usually using say that 这个才是对的，这个才是对的，因为呢，based on the latest IPAC 我们是用这个 Z 字头的，不是 S 的，所以我们不要写那个 S 的。So during eliminations of dehydrations, the measure of products of the reactions is alkene with the most alkyl groups. So alkyl group means R. The more R you form, the alkene with the more R you form, the stronger the bonds. Okay, the stable the products, the major the products. Okay, so eliminations of haloalkane will form you alkene. Okay, will produce you alkene. So eliminations here of haloalkane will eliminate out HX halide ion. So this halide ion, all are white film. Okay, all are white film. Okay, so write a chemical equation for the reactions when 2-chloro 2-methyl-butane. Okay, 2-chloro 2-methyl-butane. Okay, 2-chloro 2-methyl-butane. Okay, so this is 2-chloro 2-methyl-butane. Is reflected with ethanolic KOH. So with the word ethanol, you know that this is elimination. This is the solvent used to eliminate out potassium hydroxide, to eliminate out HCl. Okay. So yeah, right. So how was the eliminations happens? Okay, with something like this: CH2, H, okay, and CH3. So take a look on this Cl. This Cl will grab the nearby hydrogen atom. So it can either grab from here, here, or here. Nearby, okay, nearby hydrogens. Okay, it must take the countering carbons to hydrogen. Okay, countering carbon hydrogen means that it can take from carbon number 1 here, carbon number 2 here, or carbon number 3 here. I can take any hydrogen from these 3 carbons. Okay, and then these formations will form you 3 different compounds, and you have to base on the different compound, select out which one will be the major compound. All right, so like we do first one, so KOH in ethanol. So probably you form you CH2. Okay, so you can see this one I take out carbon from, I take out hydrogen from carbon number 1. Okay, from this compound. Okay, and then for number 2, it will be repeating as number 1. So I take number 3. Okay, these 2 are repeated. Okay, these 2 are repeated because they are same. They are in carbon number 1. Okay, they are in carbon number 1. Okay, whereas number 3 will be a bit different. So let's see. The compound form will be something like this. Take out 1 hydrogen, form double bonds, and forming CH3 CH, okay, do something like this, plus HCl, okay, plus HCl. Okay, so if I take hydrogen from carbon number 1, I will form A. Okay, this one is B. So based on R group, you have to determine the R group. So here is one R group, here is one R group. Okay, this one you see is CH2. CH2 is not enough as R group. So probably we have 2 plus 0. Okay, 2 plus 0. 2 R group on the left hand side and 0 R group on the right hand side. Okay, whereas for number B, okay, this one we have 1 R group, 1 R group, and 2 R group. So we have 1 R group and on the left hand side and 2 R group on the right hand side. So when we add up all the R group, we'll form this one is 2 R group, this one is 3 R group. So theoretically, okay, B will be a major product because it consists of large numbers of R group. Say the greater numbers of R group, the greater numbers of alkyl group. Okay, so B will be major, whereas A will be minor. So minor usually form around 20% and major will be around 80%. Okay, you are producing 2 actually. Okay, you are producing 2 in one synthesis. Okay, must hit it. Don't forget to hit this. Okay, any questions maybe in elimination? You have to understand every single reactions, for every chapters from every functional group because for SEM 3 questions, especially essay, it will be like giving you a synthesis, giving you a paragraph. It consists of few reactions and you have to translate all the reactions into chemical equation. And sometimes we'll ask for mechanism. Okay, so that's why teacher we're going for every chapter's reaction first. Okay, for the mind map. Okay, after that we'll go for questions. So probably after Monday, I guess Monday will be the last topics we're going to cover, and then on Tuesday we'll go for question based. Okay, we'll go for question based. We will be tackling on all types of questions that will be asked. Okay, organic chemistry very easy. Okay, it's easy compared to the other topics. Okay, like dehydrations of alcohol. write a chemical equation for the reactions with 2-isopropyl cyclohexanol. So isopropyl, okay, it happens again. Propyl mean 3-carbon alkane. Iso mean is isomeric, is identical. Okay, identical. So it's something like this. This is isopropane. Okay, isopropane, and this is isopropyl. Okay, isopropyl. Okay, this is the symmetric point. Okay, this is the symmetric point. And cyclohexanol, something like this. Okay, cyclohexanol, and then 2-isopropyl. Okay, this is the structure. This is the structure. All right, and then it's heated with concentrated sulfuric acid at 180 degree. So at 180 degree, you are probably forming alkene. Okay, you are forming alkene, same as the elimination reactions you have at above. Okay, but you're using different reagent. First, we are using potassium hydroxide, and this one we are using concentrated sulfuric acid. Okay, so by this, okay, what is going to happen here is, okay, you can actually label out all the hydrogen carbon you have. This is that. Okay, so this OH group, okay, this OH group later will combine with either, okay, either the hydrogen here or hydrogen here to form double bond. Okay, to form double bonds. Depends on the conditions. Depends on the major and minor properties. Okay, so we take the yellow color one first. So yellow color one will form double bond on the left hand side. Okay, this one is your first functional group. First compound, first alkene. Okay, and then second, okay, your bonds are forming here. Okay, and then like determine how which one will be your major compound. Okay, so really this one. Okay, this one will be your major compound. Okay, why? Because here at this double bond, you have one functional group R. Okay, whereas at this moment you only have hydrogen. Okay, this one alone hydrogen. Okay, you don't have functional group. Okay, so this one will be minor. Okay, the below one will be major because of the R group. Okay, because of the alkyl group. So this is the blue bonds form. This is the yellow bond. Okay, again, like next. Okay, this one also got another side product in case your temperature is not enough. Yeah, you cannot simply write this one. You have to write specifically. Yeah, sorry. Okay, like in case your temperature is not enough, means that you're just around 400 degrees Celsius, you're not going to form alkene, but the bond will break and form ether. Okay, the bond will break and form ether. So for example, I give you an example of a small simple alcohol. For example, this one. Okay, so in case your temperature is above 180 with the same reagent, sulfuric acid, and 180 degree. Okay, so probably you can form out alkane in this moment. Okay, so this is the alkane you form. Okay, alkane you form, and you eliminate out water molecule. Okay, but if your temperature is not enough, means that your temperature is less than 180. Okay, your temperature is just around 140 something or less than 180. Okay, it will form you an ether. Okay, so what is ether? Ether is something like this. Okay, like this is CH3. And then hydrogen. Okay, so the OH bond are not fully break. Okay, the OH bond are not fully break and left out oxygens bound to this carbon. So forming you with this COC bond. Okay, forming you with this COC bond. So this COC bond will be your ether. Okay, formations of ether. This is ether. The bond for ether is COC. Okay, COC. So that's why if you are thinking of using this reagent, okay, if you want to use this reagent, which is sulfuric acid and also sulfuric acid to form alkene, make sure your temperature is 180 lah. If your temperature is less than 180, you're forming other products. So that's why for these questions, you cannot simply put triangle. Okay, cannot simply put triangle because it is sensitive to temperature. Okay, it is sensitive to temperature. Okay, like okay, no worries. About this synthesis also no worry because we have modules on synthesizing at the back later. Okay, we'll go for some difficult structure to synthesis and also high potential structure. Okay, the first batch will be a bit boring because you just recall back all the reagent we use. Okay, like next, go for some explanation. So there are few haloalkane and alcohol that are not undergoing eliminations and dehydrations. Okay, give one reason for each of an example. Okay, so basically, what kind of haloalkane cannot undergo eliminations? Okay, so probably will be tertiary haloalkane. Okay, tertiary haloalkane. So for example, this is R bind to another R and another R. Okay, and then we have this one is hydrogen, Cl, and hydrogen. Okay, for example. Okay, for example. So this Cl. Okay, I change another position for you maybe. Okay, this is Cl. This is hydrogen. Okay, so this Cl cannot grab hydrogen from here because it's too far already. Okay, it's too far already. Okay, or in other words, we can say that this carbon number 2, this carbon number 1, carbon number 2 does not have available hydrogen. Okay, we don't have available hydrogen. So that's why the hydrogen cannot grab. Chlorine cannot grab the hydrogen and form HCl. So there's no bond forming there. Okay, there's no bond forming there. Okay, or simply I write down what's happening here. Okay, for example, I change this R2 into CH3. So you can see clearly, even though this carbon has hydrogen, but is too far from this carbon, too far from this chlorine. Okay, too far from this chlorine. So we can say that this chlorine atoms cannot grab nearby hydrogen, or in other words, there's no available hydrogen. Okay, no available hydrogen for this chlorine to grab and form double bond, form a pi bond. Okay, so how we're going to explain, we can say that there's no hydrogens at the adjacent carbon. Okay, or there's no available hydrogen. Okay. So when there's no hydrogen at the adjacent carbon, there cannot carbon cannot grab the chlorine, okay, or the electron from chlorine cannot back to carbon. So there's no eliminations or hydrations. Okay, eliminations is when we're using KOH or NaOH in ethanol. Okay, hydrations is when we're using concentrated sulfuric acid at 180 degrees, because hydrations mean we are deleting H2O molecule. Whereas ethanol eliminations is when we eliminate out HX. Okay, when we eliminate out HX. So both of these are different terms, okay, like HX. Okay, dehydration means delete hydrations. Okay, dehydrations mean delete hydration. Hydration is water molecule 的意思。Okay. Okay, so another example is this one. Phenylchlorobenzene. Phenyl, sorry, okay, one chloro phenylmethane. Okay, so same story happening. We don't have nearby hydrogen here. Okay, we always look at next to the carbon which attached it by this chlorine. For example, chlorine are attached to this carbon. Then you can look on the left and right of the carbon, see it whether we have available hydrogen. So in this case also we don't have available hydrogen, so we can't form double bond. Okay, so we can't form double bond. Same reasons. Okay, can I like explain why haloalkane does not undergo combustions? Okay, so this one is because halogens atoms or the radicals is flame retardant. Okay, what does this mean? It means that the chlorine halogens or chlorine atoms actually able to deflame your combustions. Okay, it can, you know, 可以扑灭火势，我们讲对。Okay 为什么这样呢？因为我们的 chlorine 它有很强的 bonds，strong bonds presence in between chlorine。So that's why 它比较 inert， 它比较 inert chemically inert， 所以 chemically inert 的 compound 它去到我们的 combustion 里面，它不能燃烧，它不能 break bond， 最后呢就可以扑灭那个火势，可以扑灭那个火势。So that's why in fire extinguisher 在 fire extinguisher 里面，最新的 fire extinguisher 里面how to draw fire extinguisher? Okay, it'll be something like this. Okay, in fire extinguisher also we contain low percentage of haloalkane. 原因是因为它可以扑灭火势，它的 radical 是一个不可以燃烧的compound，它不是 oxygen， 它不可以助于燃烧explain redundant. Okay. Right, next. Okay, so these depletions of ozone focus on objective also. Okay, objective only. Okay, so depletion of ozone, okay, stories about CFC. You know what is CFC? Chlorofluorocarbons. One examples of CFC is CF2Cl2. Okay, CF2Cl2. This is your chlorofluorocarbon. So chlorofluorocarbon is chemically inert as it does not decompose at lower atmosphere. Okay, yeah, it's chemically inert. It's not easily to break unless it was under supervisions of UV light. So this chlorofluorocarbon usually be used in refrigerators. Those time when you was still young. Okay, still young. You're probably using refrigerators or any other coolant or your aircon also using chlorofluorocarbons. So these chlorofluorocarbons are actually chemically inert unless it was under supervisions of sunlight. Okay, it means that under supervisions of UV light, under the strike of UV light, this will break the chlorofluorocarbons to form radicals. Okay, to degenerate and form chlorine radical. So this chlorine radical is highly energized. Okay, 它很强 energy 的。Okay, because all radicals are reactive. Okay, all radicals are reactive. So by this reactivity, it will start to attack ozone layer. This is ozone. O3 is ozone. So this radical will attract your ozone. Okay, attract your ozone. Attract until form O2 gas. This is gas. Okay, so O3. Okay, you can imagine, okay, you can imagine this is your Earth. Yeah, this is Earth. Okay, and then Earth are surrounded by, okay, this is ozone. Okay, this is ozone. So ozone is consisting from O3. Okay, ozone chemical formula for ozone is O3, and these tiny molecules are all O3. Okay, are all O3. So by the strike of UV light, okay, so this UV light strike up, and when you're using chlorofluorocarbon, okay, this chlorofluorocarbon and later will release to atmosphere. Okay, when it's released to atmosphere, okay, and at the same time struck by this UV light, it will decompose to form chlorine radical. Okay, to form this chlorine radical. Okay, this chlorine radical is very highly reactive, very super reactive. So it will strike to attack ozone. Okay, it will react with ozone, okay, to form O2 and also, okay, chlorate radical. Okay, so you can imagine this strike make this O3 turn into O2 gas and later dissolved in atmosphere, released to atmosphere. So you can imagine, okay, by this time, your ozone will get thin and thinner, okay, thin and thinner because O3 are now turned to oxygen gas 它已经变成 oxygen gas 了的。我们的 ozone 要 O3 这个 configurations 的，如果没有 O3 它就是 oxygen gas 它就排放出去了。所以为什么我们大气层变得越来越薄是因为 O3 全部已经变成 gas 了，因为变成已经 gas 了，已经全部释放出去了，所以导致呢 UV light 一直跟它射进来，变得越来越热啊。加上现在我是在这个这个 slang 这边，在那个哪里啊？等下我想一下，我很热，天天都觉得非常热，感觉很热。因为开了冷气也是觉得很热啊。OK， 就是因为越来越多 UV light 了 ，OK， 越来越多 UV light 啊。OK，so this O3 later will continue react. Why? Okay, this chlorine radical because of this chlorine radical. Okay, this chlorine radical is reactive. All radicals are reactive. OK， 只要你看到 radical 呢，它就是很 reactive 的，它会一直 continue react， 一直到它没有 energy 为止 ，until the chlorine radical loss of its energy. So the continuous depletion of energy will continuous until the chlorine radical loses its energy. Okay, loses its energy. 最后你看它一直 continue to form radical， 一直 form radical， 所以它的 depletion 是一直 continue 的。最后你可以看到说 ozone layers are depleted to form oxygen gases. So that's why global warmings happen right nowadays. Okay, so in your exam, you are required to understand the depletions of ozone by remembering all the equations happen from here to here. 你要明白它的 equation 怎样写，然后呢，箭头怎样画，这样是可以的关于 mechanism 不需要 ，okay, we don't question we don't ask you on mechanisms you just have to remember this, okay, overall equations and what is the mechanisms. I mean, like O3 reacted with chlorine radicals to form O2 and ClO radicals, and then continuous attack. Okay, and lastly, overall equation. That's all. This one come in exam before 5 marks. Okay, come in essay before 5 marks. Ask you to state the depletions of ozone. OK， 我们背一个就好了啊，背这个就好了的。Okay. Okay, so by this end of haloalkane, now we go to alcohol. Okay, today we are going to finish alcohol as well. Alcohol a little bit only. Okay, like as usual, please remember all the reaction. Okay, remember all the reaction scheme for every functional group as much as you can. Okay, as much as you can. This will help you to understand and also solve a little bit questions in your essay. Okay, 因为 Chm 3呢，只能就能背包的。Okay, let's look at first reaction. So we have alcohol. This is alcohol and alcohol forming haloalkane. Okay, this is haloalkane. Okay, this is alcohol. Okay, so first reagent you can use actually will be thionyl chloride. Okay, first. Thionyl chloride or PCl5. This two, yeah, you can use this two. Okay. Second, you can see from haloalkane to alcohol. So this one you can use hydrolysis, acidic alkaline hydrolysis, KOH or NaOH. Without ethanol. Okay, remember without ethanol. So the third one will be sodium hydroxide aqueous, or react with metal solid also can. Okay, like be specific. Come, okay. Na metal solid. Okay, this one is for aliphatic. If you have aromatic, for example, aromatic alcohol, okay, then you can use sodium hydroxide. Okay. Aromatic alcohol cannot use sodium metal. Okay, it's too reactive, cannot. Okay, cannot use sodium metal. So probably we are just using hydroxide. Okay, sodium hydroxide or potassium hydroxide. Hey, no, sorry. Terbalik, should be ONA. Okay, this one is sodium hydroxide only for aliphatic. Okay, this one is only for aromatic. Okay, right, next. From alcohol, okay, we can classify it into 3 different groups. So we have primary, secondary, and tertiary. So primary alcohol, if using a mild oxidizing agent like PCC or DMSO, then you can form aldehyde. This is aldehyde. Okay, or else you also can use potassium hydroxide in alkaline. No. Okay, but cold. Okay, but cool. This one will form you aldehyde as well. Okay, anyway, from aldehyde, you just simply heat up. It can directly form you with carboxylic acid. Okay, just simply heat up. Heat up just by warming up the beakers, or just simply heat up by holding the beaker also can form carboxylic acid directly, because aldehyde is not stable at all. Okay, it's not stable. All right. Anyway, you also can directly synthesize your carboxylic acid from alcohol, from primary alcohol, just by using stronger oxidizing agent such as potassium manganate, and make sure it's heated, or else you also can use potassium dichromate in acidic solutions, and you heated it up. It will directly form you. Okay, but remember, every time you use this kind of solutions, for example, potassium manganate and also potassium dichromate, you have to state clearly with the observations. Okay, observations. What is the color changes? So for potassium manganate, it will be purple, okay, to colorless. Yeah, this one is orange to green. Okay, orange to green. All right. And then one more thing to make sure is, okay, we are rejecting violet. Okay, don't use violet. Okay, violet is different, purple is different. All right, so in STPM mark scheme, we only accept purple, so don't use any other color than purple. Okay, like next we have number 5. Okay, done. Okay, number 6. Number 6 is a reduction process where you can just simply use a stronger reducing agent by lithium aluminum hydrate in ether. Okay, followed by acidic hydrolysis. Okay, must come with these two, then only you get 1 mark. If you miss out the hydrolysis one, you won't form your products. Okay, and also you won't get your full marks, for sure. Okay, for sure, surely. Okay, secondary alcohol. This is a secondary alcohol. Will form ketone. This is ketone. Okay, same reagent you use, which is potassium manganate heated, or potassium dichromate also can. No problems. Okay, and then reductions also same as usual. We are using LiAlH4 in ether, followed by acidic hydrolysis. And then for tertiary alcohol, you cannot oxidize it. Okay, for tertiary, you cannot oxidize it. This is tertiary. Tertiary should be R. Okay, change this to R. Oh. Okay, like continue games on this. Okay, formations of ether. Okay, this is ether bond, COC. How we're going to form ether? Okay, very easy. You just heat up with concentrated sulfuric acid, but you control the temperatures at 140 degrees Celsius. Okay, 140, must be 140. Cannot reach 180. If you reach 180, it will form alkene instead of ether. Okay, so this is ether. Okay, like next we have this one. Okay, what is this? R. Oh, okay, I remember this. Okay, like so this one is a special conditions for your alcohol. Okay, what we call as iodoform structure. Okay, iodoform structure. So iodoform structure is something like this. Okay, so this is iodoform structure. It must consist of one R group CH3 hydrogens and also your functional group. Okay, your functional group. So you in primary alcohol, there's only ethanol can do this. Okay, there's only ethanol can do this for primary alcohol. Okay, so it will form you a white precipitate. White precipitate is CHI3 iodoform. And this one we call as iodoform. reagent we use is iodine in alkaline solution. Iodine we use in alkaline solution. So this one 呢会这个呢会structure 会放到这样子的compound的。For example, I give you examples of ethanol. So this is ethanol. Okay, so ethanol have this iodoform structure. This is the iodoform structures of ethanol. So later when it react with I2NaOH, okay, so it will form CHI3 NaI. Okay, I write down the complete reaction for you. Okay, this is the complete reaction. So how would you remember this? Okay, very easy. 4, 6, 5, 5. Remember this 4, 6, 5, 5 for alcohol. Okay, 465啦. This one will be your lucky number. You can buy this 40 tomorrow. Maybe you can just simply get money and then you can quit STPM. No need to take your paper 3. Okay, all right. So iodoform structure must consist of this CH3, hydrogen, and also OH. Then only they can react with alkaline iodine solutions. So instead of using iodine reagent, you can use this as alkaline iodine solution. Okay, and this is your yellow precipitate. Okay, this is the yellow precipitate. Okay, right. Next, formations of ester. Okay, so carboxylic acid from alcohol to carboxylic acid. Okay, it must be only primary alcohol can do this. Okay, only primary alcohol. Okay, and then reagent used is Chm Int Haloalkane H plus heated. Okay, heated. To acyl chloride, you can use how is the linkage like this? Cannot link like this. Good job. Okay, erase this. Okay, should link like this. Yeah. Okay, from RCOH to ROCl. Okay, to form ROCl. Okay, so how we're going to do this? You can react just simply with thionyl chloride or PCl5. Then you get ROCl. This is acyl chloride, the most reactive derivative of carboxylic acid. Okay, the most reactive, Okay, the most reactive. Okay, so we have ROCl, acyl chloride, and also carboxylic acid. Later combined with alcohol can form ester solution. So this is ester. Okay, then must be combined with alcohol, alcohol. It must be alcohol. So these reactions must react with aliphatic alcohol only. Okay, must be only aliphatic alcohol, cannot use aromatic. With benzene ring one cannot. Okay, reagent is concentrated sulfuric acid. Okay, simply heated. Okay, simply heat it up. Okay, and then for number 9, this one can both. Okay, we can use aromatic and also aliphatic. Okay, both accepted. For number 9, both can. Number 8 cannot, only aliphatic. Okay, and this is ester. So ester bonds here shows you COO. This is ester bond. Okay, number 11 and 12. Okay, number 11 is conversions of alcohol to alkene. Okay, simply by react with you can use sulfuric acid. Okay, this is your first reagent, or you can use KO equation. Yeah, the additions only with sulfuric acid. Heated. Okay, and then from alkene to alcohol, okay, you can use reactions with water with H3PO4 680 M 380 M, 60 degree, or by concentrated sulfuric acid. Yeah, 2 reactions can produce alcohol from alkene. Okay, and then done with your mind map for alcohol. Okay, right. Please read out alcohol. Alcohol will be your one topic for your structure this year expected. Okay, spotted for your for essay, sorry, not structure essay. Okay, essay alcohol reactions. 因为我们要读 alcohol 要重要一点点。Okay， 而且还有一个是 benzene ring， 等下我再跟你 focus 下 benzene ring。Okay， like so as usual, you can transfer all the data into the tables, but I guess don't do that because wasting of time. Okay, anyway, like 看下 reactivity 啦。So reactivities of alcohol are dependent on the break bonds either. Okay, alcohol is something like this, ROH. 这个是 ROH, and alcohol can break bond in 2 ways. So first way is the breakings of RO bond. Okay, this one will probably form you either ether, ester, or alkoxide. Okay, or alkoxide. Anyway, another method is that break of OH here, break here. Okay, 所以它可以 form 到2种不同的 reactivity 碰到两种不同的 compound，OK 啊，两种不同的 compound 啦，它可以 break 这样子。OK，so why 什么东西取决于它的 breaking 呢？It depends on the polarizabilities of your oxygens and carbon bond. Okay, oxygens and carbon bond. Okay, as you know, electronegativities of compound of oxygen atoms are much more higher than carbon. Okay, so breaking of this bond are dependent actually on the positivity of carbon attached. Okay, carbon attached. Okay, so OK， 我们可以看到下面有三种 fissions， 第一种是 oxygen hydrogen fissions， 这边 OK break bonds of O and H。 OK at this moment when we have sodium metal， 通常是有 sodium metal 的时候，就比如说 OK formations of alkoxide and A solid 的时候啊 OK 它就会来 attack 我们的 bond， break 掉这个 hydrogen and then O 跑进来。 OK O 跑进来 for example 啊 OK R O H react with Na so form you R O minus Na plus 这样子，这个就是 breaking of OH bond。OK breaking of OH bond。OK and then 还有一个就是 CO bond。CO bond 是当我们要 undergo substitution 或者是 elimination 的时候。OK only for substitutions or elimination 的时候 for example substitutions of alcohol group to form ester， 也要 break 掉它的 CO bond。OK 也要 break 它的 CO bond。OK and then oxidative hydrogens 在我们 eliminate 掉 hydrogen 的时候，就是当我们要 form oxidation reaction 的时候，当我们 reacted with caminophore 的时候 ，OK，so 这三个东西重要吗？不重要，不重要啊，我们不需要知道的，我们要只要你 focus 前面的那个 reaction 全部就 OK 了的，这只是带过而已，带过而已啊。OK， 来 last for today we have the chlorination test for alcohol。OK chlorination test。OK， 来这个 mechanism please erase it. It's not under your syllabus 啊 ，no need to study that。Okay, chlorinations of alcohol, we can use Lucas test. So Lucas test is the combinations of zinc chloride in HCl. Okay, in HCl. Okay, means that, okay, if question asks you, what is the reagent used? What is the reagent used? Or suggest a reagent used to determine the presence of alcohol? Means that you cannot use Lucas test. Okay, 不可以用 Lucas test. You have to write down what is containing in Lucas test, which is zinc chloride in HCl 这样子。你要写它里面的 compound。Okay， 你要写它里面的 compound。Okay， 如果他问你 what is suggest a test， suggest a method， 这样的话你就可以用 Lucas test。如果是 reagent use suggest a reagent，reagent 是 specific 的，那么你就要用 zinc chloride in HCl。Okay， zinc chloride in HCl 啊。Okay, so to determine the reactivities of classes of alcohol toward chlorinations. Okay, so reagent concentrated HCl in the presence of zinc chloride 2. Okay, actually it's the balik, should be zinc chloride to HCl. Okay, observations. The time required for the cloudiness of chloroalkane to appear. Okay, so for first and also primary aromatic and also aromatic. Yeah, the cloudiness form only actually it's not forming. Actually it's not forming, not forming. Okay, it's not forming. Okay, secondary alcohol form several minutes, around within 5 minutes actually forming precipitate. Okay, within 5 minutes. Okay, and then lastly for tertiary, immediately. Okay, immediately. Okay, why primary and why primary and aromatic does not form cloudiness? Because no alkane form. Okay, no chloroalkane form. Okay. So this is alcohol, alcohol reactions. Okay, let's see a bit on carbonyl. Okay, so this is carbonyl. Oh my god, so complicated, huh? Like, oh, right. So I see it's a bit of format run, huh? Okay, it's okay. And don't you understand? 有点format 跑掉了啊，format 跑掉了。Okay, never mind. Later we'll edit this carbonyl compound for you again because yeah, how it in dinner. Okay, later I will update this diagram for you. Can just ignore this plan. Okay, no worry. Just ignore this, huh? Okay, like 我们看一下 next 应该没有问题。OK 了，OK 了。Okay, this one KIV first. I will update with you because format has run and also this one is wrong actually. Okay, we don't have this. Okay. Yeah. So I guess we just stop it here today, and tomorrow we'll continue again on carbonyl and benzene ring. Okay, tomorrow we'll go a bit fast. Okay, and then after Monday we'll go for question. I already sent you the second file. As you can see, the one contain questions, spot the questions lah. So later we'll focus that file particularly after Monday. We have 2 class more to continue on carbonyl, benzene, and also polymer. Okay, and also polymer. Okay, after that, we'll go for question based. Okay, so I'll just stop the recording here.